Alright, so here we're going to deal with this system of linear equations through elimination. We're going to look for opposite terms, and here we almost have them right away, 4x's, and try and cancel them out to eliminate one of the variables so we can solve for, in this case, y, and then use that answer to solve for x. So how would I do this? Well, what I would do is first rewrite them. So we have 4x plus y equals 13, right? That's our first equation. I'm going to move it over here to the right a little bit more. And then in the second equation, again, the nice thing here is that we have another 4x. So these two terms are going to be the ones that I focus on to start because they're almost opposites, and I think you'll see what I mean in a moment. Now, opposites, I'm referring to additive inverses, right? Additive inverses are opposites. And if you think about what I'm saying, I'm talking about two numbers, x and let's say negative x, that add up to 0. So those are the numbers we're looking for, right? Any two numbers that add up to 0, like 3 and negative 3, or x and negative x, any terms that cancel out. Now we want to cancel out one of the variables here so that we're left with the other variable and can solve for it. So how do we do that? Well, what we can do is essentially make one of the 4x's the opposite of the other by multiplying it by a negative value. And the idea is that if you start with any number, let's say like 5, and I want to create the opposite of 5, I just take 5 and multiply it by negative 1, right? Because that makes the opposite, negative 5. So the key to making opposites is to multiply by negative 1, especially when the absolute value is the same, in this case 5, or the distance from 0 is equal. So I could choose either of these to multiply by negative 1. I'm actually going to multiply the second term by negative 1 because that would get rid of this negative sign and that one, and I'll have that a more positive term to work with, equation to work with. So I'll multiply everything by negative 1, and now what's going to happen? Well, when we distribute the negative sign, I'm going to rewrite this second equation, we get not 4x, right, but negative 4x. Not minus 14y, but plus 14y, and not negative 2, but positive 2. And then the first equation still remains the same, right? It's 4x plus y equals 13. And so now if I add these two, what happens? Well, when I add them, 4x and negative 4x, that cancels out to 0. Y and 14y makes 15y, and 13 plus 2 is 15. And now if I solve for y, I can divide both sides by 15. Let's cancel out, right? And this is 1. So now we know that y equals 1. And by the way, I like to use addition here, and that's why I multiply by a negative. You could have also just subtracted the second equation from the first, from the beginning, and you would have gotten 4x minus 4x, which is 0, minus negative 14y, which is adding 14y, and minus negative 2, which is adding 2. But I usually like to multiply everything by a negative and then add. It just helps me keep my terms in a clear and non-confusing order for myself. Anyway, so now we know that y is 1, and that's the key. Once you've got one of the variables, you can solve for the other. And essentially you can plug this value back into either equation to solve for x. I'm going to use the first equation essentially because it's a little bit easier to work with. So 4x plus y equals 13, and here we know y is equal to 1, so we plug that in. 4x plus 1 equals 13, subtract 1 from both sides, right, cancels out, and 4x equals 12, and now we can solve because, well, if 4 times x equals 12, we can divide by 4. On both sides, these 4's cancel out. This 12 divided by 4 is 3, and x equals 3. So that's just one way that I might deal with this problem. Hope it helped. Thanks.